Hi there. Sorry, I was just hunting for bars. It normally works quite well 4G in my room downstairs, but I'm here and I'm going to do some feedback from the previous live question, the revision question, and I'm going to tell you this week's revision question as well. So here it is. This is today's revision question. I hope you've had a really great Easter, by the way, and had a bit of a break. So here's this revision question. I'd like to take a photo of my daughter standing up that she fits as large as possible in the 35mm sensor of the camera that is in the it's on the thumbnail. I have these lenses to choose from: 28mm, 50mm, 85mm, and 135mm. Those are the 4 lenses that I actually do have for my film camera. She is 75 centimeters tall, and she's standing 4 meters away. You need to make the image of my daughter basically as large as possible. On that 35mm sensor, you can treat 35mm as being the image size, if you like. Now, that is very much an A-level question. Hopefully it's getting some ideas going for A-level students already. If you're a GCSE question, if you're a GCSE student, then just use the data to calculate the magnification, which you should be able to do with GCSE skills. And you can then also describe the image made on the camera sensor. So I hoped, if I'd have remembered, I'd have brought in my camera to actually show in this video, but it's the picture in the thumbnail anyway. Maybe I'll bring it for the answers this time. I've already had some excellent emails who have read it because it's in the description already, telling me some really good answers at GCSE level and even higher. That's really, really good. I really look forward to your answers to this one. I'll read that one out one more time, and it is also in the description, and I will put it in the comments as well. And then if you've got any chat, any questions, I'll do a little Q&A at the end as well. So here's the feedback from the previous one, which was about the car. What was the acceleration of the car? 0 to 60 in 8.7 seconds. And there's some really great responses. Basically, you had to just use acceleration is change in velocity over time. But you were given the velocity in miles per hour, so you need to convert that into meters per second. And to do that, you can just use divide by 2.2 or 2.24. They both come out to 2 significant figures at 3.1 meters per second squared. I've left some feedback on the comments that we got from the last video as well, so you can go and check that out. I was surprised at some students not giving their responses to 3 significant figures. I won't name them, but you can see them. Just remember to RTFQ, read the question. You can think what the F is for yourselves. And make sure that you pick up all the little marks. So if you actually drop out a really easy mark, like not giving your answer to a correct number of significant figures, then that's really going to stunt your ability to get the high grades in the exams. Some other ideas though I asked, like, how would this compare to the actual maximum acceleration? What assumption have you made? And loads of people got that right. You'd be assuming that it had a constant acceleration, which wouldn't really be the case. Well done to Rachel and Harriet for pointing that out. The actual maximum acceleration would be higher than 3.1 meters per second squared, because initially, basically, there is not as much air resistance because you're not going as fast. So most of the force from the engine goes towards acceleration rather than overcoming air resistance. As you speed up, you get higher air resistance as well. In the comments to the last one, I put a link to a video about drag racing that I did, which I think is really good, and compares the real graph that you would get of acceleration to a kind of theoretical one. How could you actually get how could you do an experiment to get a more accurate maximum acceleration? Some really good ideas about taking a tangent. That's me actually just going up on my computer down here, so sorry. There we go, that's gone. So taking a tangent, so taking speeds at different points and taking a tangent at the maximum, doing a velocity time graph, taking a tangent to that to give you the highest possible acceleration. And taking a tangent is a really important skill in both GCSE and A-level. So that 3.1 is like an average acceleration. Do you really need to video the car though? There are some good ideas of like video in the car. there was a good idea of doing it on a different planet so that you didn't have traffic laws. I don't know why we needed that one, I'm absolutely there. But yeah, those are good points there. And then lastly, you could just really video the speedo, couldn't you? And you could see, you could watch the speed increase, and you could plot that every 5 seconds or whatever, or not every 5 seconds, every second. It's from 0 to 60 in 8.7 seconds. Plot that graph, you'd hopefully get that nice curve, and you take a tangent to that, and you'd be okay. Right, I'll do the Q&A. Well, I'll do the question one more time. So this, and then I'll just read any kind of Q&As that people have got there. This next question is, I'd like to take a photo of my daughter standing up so she fits as large as possible in the 35mm sensor of this camera. I have these lenses to choose from, 28, 50, 85 and 135mm. She is 75 centimeters tall and is standing 4 meters away. Which lens should I choose? So which one will give me her as large as possible, my little daughter, 75 centimeters tall, 4 meters away, as large as possible, but would still fit on the 35mm sensor? If you're GCSE, then calculate the magnification, but also describe the image made on the sensor. So hopefully you're used to describing images. I'll just have a little look. Which papers would you recommend you do for practice? All of them, probably, because there aren't that many, and you can definitely fit in 5 by the end if you're in A-level, okay? I want to be efficient, so don't waste any time every single past paper possible. Well, rather than do all of them then, if you really don't have time to do that, then just go ahead and do the last few questions of each one, which are going to be the harder ones. Question here asking about how to tackle 6 markers. One of my best live feeds last year, it wasn't necessarily the most popular, but I thought it was the best, was tackling longer written questions in GCSE and A-level physics. So find that out. Find that on Guerrilla Physics. If you search Guerrilla Physics longer written questions, then it's a really good go through. It's basically, it boils down to this. It's like that RTFQ point there, okay? But it's how you RTFQ. It's like planning your response. As you go through the 6 markers, you read it, think to yourself, oh, there's a clue, they want me to talk about that. That's my first paragraph. There's a clue, they want me to talk about that. That's my second paragraph. And actually build up a little plan just by thinking what are all the little clues, therefore, what are the little paragraphs you're going to write. I hope that makes sense. And then, once you've finished writing, you check back with the question and check you've done everything in the question. So the person that didn't round to the appropriate number of significant figures in this one should really look back at the question to check they've done everything they've been asked to do in the question. A characteristic of these new syllabuses is that they're asking you to do multiple things in one question, rather than in previous syllabuses, they'd have a second question for that second easy kind of skill. Yeah, they'd split it down a bit more. Yeah, Addy Daddy says that they're talking about the old spec. Again, yeah, I would just do the last questions then, the harder ones as far as possible. IAL and the international A-level ones are good as well. Jacob, if you haven't seen my video, Practical to Measure Internal Resistance, then go ahead and do that. I haven't brought up the pen, so I'm not going to draw diagrams and things for you now, but internal resistance is basically like saying that the power supply is a component in the circuit, and it also has a resistance, so you have to account for that. So it is another resistor in series with the rest of the circuit. So the potential difference supplied, that's the EMF, is shared out between the resistance of the circuit and the resistance of the power supply. So it is essentially a resistor within a potential divider, so you have to account for that, doing that there. Okay, hope that makes sense. Revising practicals. Again, I've got a really good video talking about revising the practicals. For me, it's focusing on the evaluative techniques, but really you need, if you haven't got one already, a really good method to memorize for every single core practical, and make sure that you know some typical kind of maths, the analysis you need to do, and make sure that you know how to improve the practicals, so the evaluative points, because those are going to be the answers to all of the practical questions. They're going to boil down to, do you know your evaluative points for those, any practical they could give you. I hope that makes sense. All right, last little bit then. I'll just repeat the question one more time. If you have a magnet field and it drops through a coil of wire, I say the changing flux linkage between the coil of wire. Does that make sense? Yeah, it does. Yeah, absolutely. So a change in flux linkage means that it's either moving from north to south, so the polarity of the magnet's changing, or that a conductor is moving through a field that is not uniform. There's an important point there. If you move through a uniform field, then the flux linkage doesn't change because the field is the same strength throughout. It has to be either coming, getting stronger or weaker, or changing from north to south at that point for there to be a change in flux linkage and hence a induced EMF. That's why you don't get it if you leave it still, if you leave a conductor still inside a magnetic field, you don't get that. Do I think the grade boundaries will get higher? Yes, over time they will, but not by much each year. If you add like 2% to each grade boundary, that's a good kind of rule of thumb for each year. Okay, so one last time then. I'd like to take a photo of my daughter. I do that quite a lot, you can probably imagine. I'd like to take a photo of my daughter standing up so she fits as large as possible in the 35mm sensor of this camera. I have these lenses to choose from: 28mm, 50mm, 85mm, 135mm. She is 75 centimeters tall, bless her, and she's standing 4 meters away. Which lens should I choose? As tall as possible, but still fitting on the 35mm sensor. And if you're a GCSE student, then just use the data to calculate magnification, but also describe the image made on the camera sensor. So tune in tomorrow for daily revision question number 6, and I'll do feedback on that. Put these in the comments to the main thing. This is all about just taking your knowledge and applying it to some questions. So it's a good way I think the best way to revise is to actually try and use that knowledge, get used to applying it to some situations so that you're not completely lost in those exams. This is Gorilla Physics. Subscribe so you don't miss anything. And I'm looking for you getting those A stars and getting those grade 9s, learning to apply that knowledge. Make sure that you think of an answer, give it a go, leave it in the comments. I will respond to them, and I'll see you tomorrow on. I'm going to pick the best GCSE one and the best A-level one. Ta-ra for now. Happy revising, and hope you enjoy being back at school tomorrow. We were back at a training day.